Okay, next lecture. This is chapter 3, section 2, and it talks about a linear programming problem. In this section, we take word problems and put them into a form that you can work with. Now, what I try to do, and I'm a little bit different than the book, I'm a little more organized than that, but I try to break things into steps. And if you follow these steps, you'll keep organized and it will help you get the answer. So I've got the steps written down here. First thing you're going to do is define what your variables are. Number 2, you're going to draw a table if you can. You can't always do that, but if you can, put a table, and that organizes your data and makes it easy to find your inequalities. Next, you find the inequalities, and there's what they call a profit or sometimes a cost function. So many of these applications are geared towards a business type application or problem, and with business you either have a profit or you end up having a cost. Later on, what we want to do is maximize our profits and we want to minimize our cost. Okay, once you have the inequalities, you need to graph them. Neatness is very important. Use your straight edge. You have to use graph paper. It won't make sense if you don't. Once you have the graph, I'm getting ahead of myself because this is really the next section, but we're going to find the vertices. Then we're going to plug each vertex into the profit or cost function, and then we're going to decide the answer. Okay, so basically in this section we're just doing this part right in here. So section 3.1 we kind of reviewed inequalities and did some basic stuff with it. In 3.2 we're going to be exposed to the problems, the word problems. I'm going to call them word problems because I think that makes sense to you. And we're going to go this far. The next section, we put the rest of it in, and then the rest of I think there's one more section where we actually do the whole thing. Okay, I'm going to work 2 examples to show you the steps. In this section we'll stop once we get to the graph. Then section 3.3 we'll finish the problem, same thing I just said. Okay. So, let's look at a maximization problem. Hopefully you've already printed this out and had a chance to read through it. I'll read through it real quick though. A furniture manufacturer makes 2 types of furniture, chairs and sofas. For simplicity, divide the production process into 3 distinct operations. There's carpentry, finishing, and then upholstery. Whatever those might be. The amount of labor required for each operation varies. Manufacture of a chair requires 6 hours of carpentry, 1 hour of finishing, and 2 hours of upholstery. Manufacture of a sofa requires 3 hours carpentry, 1 hour finishing, and 6 hours upholstery. Due to limited availability of skilled labor, as well as tools and equipment, the factory has available each day 96 labor hours for carpentry, 18 labor hours for finishing, and 72 labor hours for upholstery. The profit for each chair is $80. The profit for each sofa is $70. How many chairs and how many sofas should be produced each day to maximize the profit? Okay, so first of all, we need to define the variables. Let's see here. So normally we use X and Y. So before I say what the variables are, I want you to think, what are we trying to find? Aren't we trying to find the number of chairs and number of sofas being produced? Look at the profit function, that'll tell you right there. So X is going to be equal to the number of, let's say, chairs, and Y will be the number of sofas. Okay, so if we go back to the first page, first thing we were supposed to do, define the variables. So I've done that. So now we need to come up with a table. Okay, well, first, you're going to make a table, but sometimes it's hard to understand how big to make the table. Okay, so one thing I'm going to know is I'm going to put chairs and sofas on the top, and then my limits, what I call the limits, would be over here. Now this side is blank because I'm going to put some things down here. What are we limited on? Well, in this problem there's three things. If you go back up here, we've got three operations. We got carpentry, we got finishing, and we got upholstery. I'll abbreviate. Carpentry, finishing, and upholstery. And then you got one more line down here, and it's either going to be profit or function or cost. In this case, it's a profit. If you go back right here, this will tell you that word right there, maximization. What do you want to maximize? Do you want to maximize your profit, or do you want to maximize your cost? Well, I don't want a cost that's really big. I want to keep that small. We want to maximize profit. The bigger the profit, the better. So this is a maximization problem. We're going to find the profit. Okay, now let's go back here. We got to break this up into pieces. Manufacture of a chair requires 6 hours of carpentry, 1 hour of finishing, and 2 hours of upholstery. So a chair is going to take 6 hours of carpentry, 1 finishing, and 2 for upholstery. For a sofa, it's 3, 1, and 6. When you read the paragraph, and you got numbers everywhere, it's hard to understand, what goes where and how it relates and all that. By coming up with a chart, then you kind of organize your numbers. Now, let's talk about the limits. We're limited availability, skilled labor, as well as our tools, blah, 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 and so on. So 96 hours for carpentry. 18 hours finishing, and 72 for upholstery. Now, I don't really understand what all that means, but for what we're doing, the numbers make sense. Okay, and then on the bottom, for my profit for each chair is $80, and profit for a sofa is $70. So at this point, I've got my chart filled out. Okay, so the next step says we want to find the inequalities. This is the easy part. We're going to produce, remember, the number of chairs produces X and Y is the number of sofas. So if I'm going to produce X chairs, that means I got to put 6 hours in for each chair, so that's 6X. Okay. For carpentry, I'm going to add on 3Y for the sofas, and that has a limit of 96. Okay, and that's going to be less than or equal to. I can't go over 96. I've only got 96 available. When you go to finishing, I got 1x plus 1y, or just x plus y is less than or equal to 18. And then 2x, this is for upholstery, 2x plus 6y less than or equal to 72. Now that's your three main inequalities. Always remember this though, if I ask you for the inequalities, don't forget these. And you're going to say, well, where did those come from? Well, it's obvious. When you look at the problem, are you going to produce a negative amount of chairs? Or a negative amount of sofas? No. In the business world, you're not going to do that. So that means x always has to be greater than or equal to 0, and y has to be greater than or equal to 0. Okay? What about the profit function? Okay. P for profit. P is in terms of x and y, but we'll just write it like this. My profit, I get $80 for each chair. I'm producing X of them, so I'm going to have $80 for each chair, plus $70 for the sofa. So this becomes what they call a profit function. Okay. Now what? Well, now we're going to have to do some graphing. Let me get a piece of graph paper. Hopefully I can. Oops. Where's my graph paper? It's always there till you need it. Okay, so first thing I'm going to do, I'm going to copy my equations. So I've got, of course, x greater than or equal to 0, y greater than or equal to 0. I've got 6x plus 3y less than or equal to 96. I've got x plus y less than or equal to 18. And I got 2x plus 6y less than or equal to 72. Okay, let's go up here. I'm going to change pins so it's not quite so big. Let's talk about the x and y coordinates of each of these. Usually I put x equals and y equals, but sometimes I just do it like this. Okay, get rid of that. Too much confusion. So, the x-intercept here, if you cross off, use my pen, 6x equals 96, so x is going to be 16, and the y is going to be 32. On the second equation, they're both going to be 18. And a third equation, let's see, x will be 36, that's 72 divided by 2, and the y, that's 72, that's a 6. It's 12. So now, coming down here, let's see, how do we want to divide this up? Well, I don't know. See, I got about, let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 36 is my biggest number here. So if I went by twos, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. I'm going to use that 36 here in a minute. We'll do the same thing going up. Each one of those is 2. Let's start with the bottom line. I don't know why I did that, but 2, 4, 6, 8, 10. There's 12. So if we're going to graph that line, get a bigger ruler. Okay. And I can see right now I'm going to have to extend this out. Okay, so that becomes, that was actually line 3 that I did. Okay, let's go back to line 1. X is 16, so 2, 4, 6, 8, 10, 12, 14, 16, and 32. So I got 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. 32 is right there. Okay, so there's L2. I'm sorry, it's L1. That was the first equation I had. Okay, and then 18 and 18. So 12, 14, 16, 18's right here. Let's see, I already had 16, so 18's right there. So there's your 3 lines. Now, if I was shading, remember that you're going to have everything that direction because x is greater than 0. And coming up from the y-axis, I don't want to make these really very dark, just enough so I can see them. And then for each of those lines, they're all less than. So for this line, it would be all of these. For L2, it's all of these. They're all below the line. And for L3, it's all of those. So what's the shaded in region? Your book calls it the feasibility region. Other books, most books, call it the polygonal region. So the intersection flip it around. Now you can see your polygonal region or your feasibility region. Now, before I break off, I'm kind of getting into the next section, but I want you to see this since I've got the graph here. You've got this polygonal region, and if it were me, I would darken the edges. Neatness counts. That makes the whole thing just a little bit better. And then of this polygonal region, you have 5 vertices. You got one there, one there. There's a vertex here, a vertex here, and a vertex here. And the next section we'll find out what the coordinates of those vertices are, and I'll show you what to do with them. Okay, I'm going to stop there, and in part 2 I'll give you another example.